Yeah, good morning, students. It's my pleasure to introduce this another topic on the comparison of time complexities of the linked list operations. So now I would like to share my screen. So hope my screen is visible. So this is the week 10 lecture 3. So the classroom discussion topic is on time complexities of linked list operations. So the summary of the previous CDT is that we discussed about the linked list implementation of stack operations using linked list. So we discussed about how the push operation and pop operation and then display operation is implemented. So push operation is similar to insert friend in a single linked list and delete friend is nothing but a pop operation. And the normal traversal is nothing but the stack contents. Fine. So now the current today's session is objectives are the time complexities of linked list operations, various operations that can be performed on linked list. We are going to compare their time complexities. So outcome of this session is that upon completion of this CDT, students will able to analyze the time complexity of different linked list operations. Fine. So we already discussed about what is meant by time complexity and what is meant by space complexity in the first unit itself. So time complexity is defined as the number of uh, time cycles that particular instruction set is executed. Okay, so it is because the total time taken on some external factors like compiler used and the processor and speed of the processor, etc. We are not considering that, and we are just counting how many instructions are there, and we are assuming that every instruction takes 1 unit of time for execution. Space complexity is nothing but it is the total main memory space that is required for the complete program execution. So that is the space complexity. So the advantage of linked list comes when we have to insert an element at current location or delete current element. This is done in constant time as we need to change the address stored to previous nodes only. So in case of array, same operation, if we need to perform, we need to shift all the elements, which makes that time complexity to a linear time complexity. So operations at the end of linked list like inserting element at the end takes linear time because we have to traverse to the end. So if we are already at the end, then we can insert an element in a constant. So these are the single linked list operations. Based on that, we are writing the time complexity. So if you want to access ith element in the single linked list, so you have to approximately the time taken is order of n because we have to traverse that. So traversal of all the elements in a single linked list also takes order of n time. So if you want to insert an element e at current position, so it is a constant time it takes that. Deleting an element which is present at current location, it is also take constant time. Inserting an element e at front, it also takes a constant time. So inserting an element e at the end, it will take order of n time because we require here the traversal time plus order of 1. Fine. So that is what we are confining the time complexity of a linked list. So time complexity of circular linked list operations, if you take the beginning, end, and other than given position, if you take it as so insertion operation at the beginning order of one constant, at the end order of one, and then here order of n. So one thing here you can observe that the difference between the time complexity of single linked list and circular single linked list is that inserting a node at the end, because here in single linked list it will take order of n time in single linked list because of the traversal time is included here. But in circular linked list, because the last node is having the pointer to the first node, so we can remove with one constant time. So deletion also beginning order of one, and but end if you want to take linear time complexity. Okay, so that is big O of n and big O of n. This is a time complexity of double linked list operations here. So if you want to access all the elements one after another in a double linked list, you can take order of n. And if you want to search an element, order of n, and insertion order of 1, and deletion is also order of 1. So similarly, now we can tell me what is the reflection spot here. So what are the time complexities of linked list operations? So if you are not able to answer these questions based on different operations, what how much time it takes that. So if you are not able to understand, please watch the video from the beginning. Okay. So thank you. So the lecture outcomes are revisited here. After completion of the session, students will able to analyze the various operations and their respective time complexities of linked list. So this is a summary of this today's session here. The single linked list and their respective operations and the time complexities of those respective operations. And this is a lecture level practice problem. Analyze the various operations of linked list along with their time complexities. And these are the further readings on this particular topic. So Devasis Samantha textbook and these are the other references. Fine. So thank you, Vananda.